All right, hello everyone. We are doing a design review for Wolfram Language version 13.2 of astronomy functionality. And this is part 3 of a series dealing with a fairly major new area of functionality. So let's get started here. So which function are we starting on?
Astroposition is the fundamental object first.
Okay. And so if I say, for example, here, let me just check I'm running the correct version. Excuse me. All right, so if I say just like astroposition of Pluto, what's happening right now?
The first time it has to load the system.
Do we want to put a progress monitor thing there?
We could. We could.
All right, we already talked about these negative things being wrong and the icon being wrong, right?
Yes, though I don't. What could be a good suggestion for an icon here?
I don't know. Why don't we get the design people in here? I mean, I think that's too cutesy, way too cutesy. What do we have for geoposition?
For geoposition, the thing is that with a single position, we don't have anything. And with multiple positions, we show the points.
Okay.
The thing is that this has a lot of information inside, so it's not so nice to show.
I don't understand why we don't just show a basic, projection with a point here. I mean, or something. We just don't want something cutesy like this. There's no value to cutesiness here. I also think, why does it say north-south, north azimuth?
Because azimuth can be measured from north and from south. It's to disambiguate that.
But what's the default?
The default is north.
But don't people usually say azimuth and altitude? And don't they usually mean?
In general, they mean north, but there are cases in which it's south.
Okay, but we don't want to put in everybody's dangle under everybody's nose, something like that here. We want to keep this as simple as possible.
Okay.
And so I mean, is the frame really the top thing, or should it be the bottom thing?
I think it's the most important thing. For what's the reference frame you are using?
And also, this font is too big here.
Yes, it is the default typesetting of dates. Okay. But
look, the distance seems very relevant here. I mean, honestly, it's like these are spherical coordinates, radius, and these are theta phi. I would just say, I would say distance, azimuth, altitude, because honestly, the azimuth and altitude, unless you're actually manhandling your telescope or something, you're probably not going to really care what those are. Those are just, yep, okay, they're numbers, that's good.
I mean, think of geographics and astrographics as being basically 2D systems, in which case distance is really just meta information because it's a 2D system. So if you think of it as, yeah, I mean, geographics is 2D, it's not 3D. Same thing with astrographics.
What Jeff is referring to is stars. So for many objects, we don't have a distance, and we just place them in the celestial sphere. So distance, we always have the two angles, but not always the distance.
Don't we know the distance to the stars?
Some of them.
We know parallax.
Yes.
Not for all of them. For some of them, the parallax angle is too small to measure.
Okay.
I want to say Hubble, Hipparcos in the early 90s. I think it was limited to something like 900 light years. And beyond that, the parallax angle became so small, it became highly error prone. So anything beyond that was not really easily measurable.
Okay. So, but if I say is there an astro distance?
Yes, you can compute astro distance between two objects.
Well, so if I just say astro distance, Pluto
I'm not sure we have information for series. Oh, it's downloading it.
Wow. Okay, now what happens if I want to know what it is next week?
In the add the date in the third argument.
Nice.
I thought this would work. It should.
Okay. All right. Fine. Okay. Is that documented to work?
Not yet. No.
I think it should work because I think it's something people are going to routinely want.
I don't. Sorry, I don't think I have a reference page for astrodistant yet.
Okay. Okay.
Now, what you can do is astroposition.
By the way, astro distance of one argument is presumably the distance from the center of the Earth. Is that correct?
I think so.
Is it distance from you or distance from the center of the Earth?
I think it defaults. I think it defaults to your actual position.
Okay, fine. Okay. And so then the other case is, I mean, you should be able to say dated of blah, right? So we should be able to say something like astro position dated Mars, comma, whatever it is.
Yeah, I don't think this works yet, but yeah, I think it should work.
Okay, fine. I mean, no, I don't mean astro position. I mean, well, astro position of dated should work as well, but I mean astro distance here. Oh, lovely. Okay. Wow. Okay, so if I say this for
try now a date in the second argument.
By the way, I just want to report the bug. You see this? This is off center. You know, I'm at 150% magnification, and this thing is off center. Aubrey, that's for you, please.
Pass it on.
Don't you think we should just return it in light years?
Yes, I think so. Actually, try astroposition of Betelgeuse.
Okay. And by the way, why that? For goodness sake, somebody needs to fix that autocomplete. Okay.
I see. Yeah, it seems alphabetic. Yeah.
Yeah, it's completely wrong. Right. So can somebody please get that right? Aubrey, please report that.
Yeah, will do.
That's good. It's far away. It might blow up soon. Okay.
So try astroposition of Betelgeuse. I think it does convert into light years in astroposition.
But I can't see. It's in kiloparsecs, which is
actually changes to kiloparsec. I see.
It's not great. I mean, I think you should just, with astro distance, you should just, since it's got units, you should just make it be reasonable units.
Yes, it's just that astronomers at some point change immediately to parsecs and kiloparsecs rather than light years.
Yeah, well, fine, but I mean, then they. Yeah.
Yes. Personally, I think light years are more useful than parsecs, in my opinion.
Yeah, and the entity, the star entities, use light years as well for distance from Earth. Check the chat window for an example.
Okay.
So it'd be nice if that's consistent with each other, whatever the choice is.
Yeah. Okay. All right. Okay. Let's look now. So we've been looking previously at astro position. Have we finished looking at astro position?
No, it has many freedoms. And
okay, let's take a look. Okay. If we just are treating this as azimuth altitude and it's the northern azimuth or whatever, then, you know, we should just say azimuth here because this is confusing.
Okay. Yep.
Okay. Okay. So what's that? I want to see what's that null island in space. What the heck is that?
Oh, that's yes. That's a to do for me to do something there.
Okay. Where am I storing these things? Do we have an astronomy area here?
I don't think we do yet.
Okay, let's start it off. What should that have been?
It's 0, 0. It's still internally 0, 0. So it's your north. It's
but it says azimuth altitude should be. It should just
0,
say
0.
0, 0, 0. Okay, fine.
Yeah. Yep.
Okay, so now how do I find the star that's closest to that?
So if you say, for example, astro position of north should give the same thing. North
So
as a string.
This is broken in some way.
Yes, I think so. It should have returned. So try the string north.
Well, I mean, I'm trying to understand what. This
I see.
Okay, that worked. So there's a minor glitch there.
Mm-hmm.
Okay, so now I want to know what's the closest star.
Interesting. I don't. We don't have a function to compute that yet.
Okay. Okay. Can I make an astrographics of right around that area?
Well, let's try astrographics. It may be broken in the xkernel. I have been changing it a lot. Try astrographics, bracket. And let's see what happens. Yep. It's working.
It's not. It is working, or it's not working.
No, it's not working. It's not showing anything like that.
Okay. Do you want to share your screen?
Yes, I can.
Okay. Now we're going to go back to astro position.
Yep.
Okay. Go ahead.
Okay. So, so these astrographics, and
can you make that bigger so I can? Just
yes, it's actually it's one.
Make that particular image bigger.
Yep.
Okay.
Yep. So
are those the brightest stars?
Sorry. Sorry, I have something else. So let me do this again. Yes. So by default, it shows the about 1,000 stars, and it labels about 20 of them.
The brightest ones.
The brightest ones, yes. And so the idea is that 0, 0 is here. It's north. Then that's Polaris. So right above.
Go over Polaris for a second. Go over mouse to Polaris. Okay, so it's giving. Okay, it gave Polaris, and that's.
So yeah. So those are equatorial coordinates. And we should use quantities, and then it's a magnitude 1.97.
Okay, but so it needs to say magnitude or something.
Exactly. Yes. Yes.
How do you usually notate that? And what's 600?
Magnitude just mag, something like that.
Okay, and 6200.
That's effective temperature.
Then for goodness sake, it should say kelvins.
Yep. Yep.
And if we wanted to be cute, we'd color it the color of that effective temperature.
Yes, in fact, the stars have a color. It is they are very small, but they are colored with their.
No, I'm saying color. That the actual. If we wanted to be cute at mouse over, we color the 6200 kelvins with the color.
Yeah.
And let me do the mouse over again, please. Hover again. Okay, the border is way too thick.
Mm-hmm.
I also think that the background should not be black. Can we ask somebody from design about that, please?
Yep. So this has a label for about 20 stars, and then the other ones, they're about 1,000.
Okay, can you show me, can you show me Mars? Mouse over Mars, please.
Yeah, Mars, I don't think Mars has a tooltip yet, but it should
Okay.
do.
And the moon as well, and everything.
Yeah, exactly. Yes.
Okay.
So this is the horizon. So this line, this horizontal line, is the ground.
Okay, wait a minute. You had grid lines previously, but you don't anymore.
Yes, I had some sort of default setting, but we can add Astro Grid lines.
Yeah, I'm a little bit concerned about the data size when you have all of those tooltips. Not sure how useful all the random little tooltips in end up being, and I'm not sure that that's. I don't know. You should figure out whether there's a data size problem.
It could be something that you opt in rather than having them by default.
Yeah.
So then the moon and the sun are visible. They are enlarged. They are, in actuality, they are smaller.
Okay, I don't understand the grid lines. Why is that? Why is that the correct project? I mean, are those lines of altitude and azimuth?
Yes.
Okay.
And so altitude 0 is this line. So we are thinking of actually coloring this part darker or something like that to represent this is the ground. This is the part you don't see.
Yes. I mean, I would sort of gray it out somehow. I'm not sure. Do we have anybody from design, and do we need somebody from design to look at that? I mean, I would think that what you want to do. Let's see how to do that. I mean, you've already got black. This is a design problem. I mean, should we find somebody from design for this meeting? Should we have them in this meeting, or should we collect pieces?
And I think we should focus perhaps on the physics and the designs and
all right,
the
okay,
maths.
So this is a design item. Aubrey, please make sure that maybe towards the end of the meeting we can pull Jeremy or somebody else from design in and go through these. Okay.
So one question is what to show by default. There are multiple things that we could show. And so here I have some defaults. And when I activate this, then we will get something bigger, and we will get also some lines, which are the fundamental planes. And so it takes time because it's processing the background image. And
why is it processing the image? Why isn't it just going splatteroo and putting the image up there? I mean, nothing's, there's a background when nothing is moving, right? They're the fixed stars.
But it is moving because we are looking from the Earth. And so this whole thing is rotating. If we look at it sometime later, it will be rotated.
I understand, but so what transformation on that image is being made to represent that rotation?
It's performing both a rotation of the Earth, and then it's performing some corrections by various things like refraction, things like that. So it's
so wait a minute. So it's doing non-trivial image processing on that background image.
Absolutely, yes.
And is it significant? I mean, is it visible? Things like refraction corrections?
Some are visible, yes, like
refraction can be up to what, a degree or so?
Yeah.
On the horizon?
Yeah, but I mean, can we? Okay, listen. You need to make that faster. I mean,
So for example, a way to see the difference is astro background goes to black. So with this, I remove the image and just make it something black. So you saw the difference between the computation of the image and with the image and without the image.
Okay.
And so here we see some lines. Now with a black background, they are kind of thinner. So this is the ecliptic. So this is the path where you will find the sun and the planets. So the sun, Mars, Uranus, Jupiter, Saturn, Moon. So they are all along this line.
Mm-hmm.
Then we have here the brown line is the plane of the galaxy. And then the purple line, which is here too, is the equator of the Earth. The projection out of the equator of the Earth.
Sorry, which line?
Yes, it's not very visible.
Visible line.
It's for some reason when I activate the black background, it looks kind of less visible. So you see the lines there?
Yeah, but where's the ground is the blue line.
The ground is the blue line.
I think these. I don't know how to gray down the lower half, but we need a way to do that.
Yes.
And I think these colors are a little bit random.
Mm-hmm. Yes.
I mean, the plane of the ecliptic seems to me, if anything, should be a yellowish color to indicate the sun. You see what I'm saying? Green is not. Why is green the color of the ecliptic?
I think green should be the horizon because that sounds like grass.
Fine. And all right, so the plane of the ecliptic, I think, should be a yellowish color. And you've got another thing, which is the projection of the equator of the Earth. Right?
Right. So there are 4 main planes. And so, for example, if we do this other computation now in equatorial coordinates, now the plane that becomes flat is the equatorial plane.
Okay, I think that should be a dotted line of some kind. The equator.
Mm-hmm.
I don't know why, but that's, I mean, it's kind of like, actually, I mean, on globes, don't you see, I'm forgetting, I haven't looked at a globe recently enough, but there's some conventions for how the equator is indicated on a globe.
I see.
But I think a dotted line is an appropriate thing. Okay, so is there a 4th one of these lines here?
There are 4. So the plane of the galaxy that you see, it's aligned with the galaxy and goes through the center of the galaxy here. Then there is the ecliptic, the equatorial plane, that they cross in the equinoxes. So that's the autumn equinox, and that's the spring equinox, and that's the autumn equinox, which we just passed. So the sun is very close to it. And then this is the horizontal plane. So these 3 are essentially fixed. This one is rotating as time passes.
I understand, but also we need I mean, the color that you're using there for the Milky Way, that seems okay. I don't know. That's another design item, please.
Mm-hmm.
Now, something me and Jose discussed is whether or not we want equirectangular to be the default projection for this horizon system. Because if you made this the default would be looking at the zenith, your horizon would just be at the edge. It would just be a circular region, right? Do you have that example, Jose?
Yes.
Then you wouldn't have to worry about shading out the area below it because you would only be seeing the sky above you.
Yes. So we have been discussing having maps of this kind in which you see the sky around your area.
You know, that is the much more familiar astro map, isn't it?
Yes. There is a tendency to use azimuthal projections with the stellar maps. Yeah.
I mean, that's what one normally sees. I think there's an argument for using this one by default. Now, let's talk about the framing of this. Can you make it a little bit smaller so we can see the full frame?
Yep.
Why is it dragging so much when it changes size?
The image is large, and it has thousands of points with tooltips and colors and things like that.
Okay. Why is there -1, -2, -1? What the heck does that mean?
These are the projection. These are the coordinates in the Lambert azimuthal projection, which is traditionally down from -2 to 2.
But those are irrelevant.
It's irrelevant, yes.
And on the left-hand side, they're also part of the actual Lambert azimuthal projection. So basically, we should just have this without the frame.
Mm-hmm. Yep.
That seems right to me. And I think having a a tooltip on the grid lines might be useful.
I see. Yes.
I much prefer this to the equirectangular.
Mm-hmm. Okay.
And I see. So you're asking also the question, do we actually want the cuteness of that background? I think it's nice to have that background Milky Way.
We were thinking perhaps of having some sort of vector approximation so that it shows in these faster maps.
Yes, why not? You don't need, I mean, yes, I think that's a good idea.
One point of clarification here, Jose. So right now we're looking essentially, is this centered on your zenith? Is that correct?
No, the
Okay.
zenith would be this one. So this
Okay.
is the horizontal plane. So this is up below ground. This is above ground.
Right, because you're
This
saying the
is
south.
north.
You're saying the south, but this is the entire sky, right?
This is the entire sky. Yes.
Yeah, I don't think that's what we want.
So we could cut it here, which is what you're saying.
I think the horizon should match up with the circle you see here. The visible area should be your horizon, I think.
I see. Yeah. So I think I remember what you were saying before. So what you want is to center the sky at the at north, which I think is here. Centering. And then we want to only show so we want from 0 to 90. And we want to No, I think this is already. So it's something, this is the, right. So now this is your zenith and this is the ground.
I don't know, but Jeff should say. But this seems more sensible to me. I mean, this is what you actually see in the sky. Now, all that stuff that is outside of the disk, I don't think we should show that.
Yes, this is not doing proper clipping, but it should.
Okay, but so we want, the things you've shown as these examples, there should be some very easy way to set one option to get to the three cases that you're showing here. This one here, I mean, because you've got, scroll up, you've got like a zoo of options here.
Yeah.
So what's the sort of bank switch version of this that you want? This is kind of like, I mean, do you want a second argument to astrographics that just says one of, just has string values? It's one of several string values or something?
I would like to keep the parallelism with graphics and geographics in the sense that it's always primitives and options. We could have something like astro range goes to up hemisphere, or even astrographics up hemisphere, and it shows directly this.
Well, you're saying, just like we have in the case of, we have a primitive in geographics.
Right. In geographics, you can do something like world, and then it will show the world map. Right? So we could say astrographics
of sky.
Wouldn't this just be a plot theme?
No, that would be more like controlling colors and other things. This is just the area you want to show, and then astrographics will choose automatically the best
projection. If I might say so, the sky is up.
Yes, but I mean, there is a complementary part to this, which is down, the sky below you.
But I understand, but the sky is not, you know, except in Greek mythology or something, the sky is not below you. The sky is up. I mean, we could have something like local sky or something, but I think we should just say astrographics of sky, astrographics of like celestial sphere or some such other thing is the case of the full of all around. Is that right? Is that the right usage?
Yes, this is the full celestial sphere. So this is north, and all these points are south.
Right, but I'm saying that as a name, it's like astrographics of sky, blump, or astrographics of like local sky or something might be better. Astrographics of celestial sphere. Okay, does that make sense? So why don't we type that? And then maybe we want astrographics. Okay, so those define. Okay, now we want to be able to say easily the different ways that this
it's very common to want to turn on different coordinate grids. Even if you've got just your sky, your local sky showing, you may want to see the equatorial grid overlaying on top of your local sky.
Yes, I was planning to do this via astro grid lines, and then you say here the various equatorial and right, and have the lines there.
Sorry, I didn't understand. Could you say that again, Jeff?
So it's quite common. Let's say you're looking at just your local sky. So your horizon is the edge of the disk that you're seeing, but you want to turn on different grid lines. I mean, by default, it's fine to show altitude and azimuth, but you may want to see equatorial. In other words, you want to see the grid lines coming from Polaris.
I see. Right.
Because if you have a telescope that's tracking the sky, it's going to follow the celestial equator, not your altitude and horizon.
Right. So right now it's showing always the astrogrid lines associated to the celestial system that you preferred here. But yeah, I was planning to activate all of them separately, and you can specify here the standard specs for grid lines.
Okay, but hold on. This Lambert azimuthal. Is this? I mean, that's the name that projection would have in a geoprojection. But what is its name in astronomy?
I don't know that it's commonly used.
I mean, they use the same projections. It's just that they use a different set by default. For example, for maps of the galaxy, the standard one is Molvida. But that's the same name. Sorry, that's the same name in the astro community.
Okay, but what's the name? Yeah, I've seen that one. Right, but what's the name for this? I'm confused here. The fact that we're calling it Lambert azimuthal won't most astronomers be, what the heck is that?
Yes, there's quite a few projections that I don't think astronomers even use. So that's why I think
I know, but that one, but hold on, but that's one we're using as a default. So what would an astronomer call that? They call it an azimuthal projection, or what would they call it? Or would they not even discuss the fact that it's a projection?
It does appear. It does appear in books. I mean, there are multiple azimuthal projections, and perhaps another one like there is stereographic too. Let's say.
But I mean, which one do people usually use? I think we need to know the answer to that so that we know which one to make the default. What does stereographic look like here?
Let's see.
That's funky.
Yep. So in the stereographic projections, planes are either circles or lines. So this here.
That's rather cool. Yeah, okay. Boy, spheres are complicated things. Okay.
Yeah, this one.
Okay, but I just want to know which one is the default. I mean, which one is the astronomer's default, and how do they refer to it?
I would say that probably this type of view using azimuthal equidistance would be the nicest thing.
Okay, well, let's see it.
So the nice thing of this one is that these intervals have the same distance. In Lambert azimuthal, they get shorter and shorter.
Okay, well then let's use this. I mean, let's decide what the default is and use it. I mean,
yep.
And but we probably need some astronomy-friendly names for. Okay, let's go back and look at these options again for a second here, please. Okay. Okay, this Astro Observer thing, I'm not a big fan of that name. So what's in that bucket?
So this is the second argument of astroposition. Effectively, what we have here is an observation, and this is defining who and in which orientation is observing and when. So you can specify the orientation, the date, the location. You can say here or some other point of the Earth or whatever. And then there are parameters. Are you using refraction? Are you considering light time? And so it will compute the positions of things when they emitted the light. Things like that.
Yeah.
Deflection
Are you
by
sure
the
this
sun.
thing shouldn't be itself a head, have a head?
Like observer, something like astro frame. I call it a frame sometimes. Or it's also sometimes referred to as a reference system.
I don't like the name Astro Observer because, not least because I've been working on this thing I'm calling observer theory, but which is not completely unrelated, but is a little bit bizarrely different.
We already have a symbol that might be reusable here, which is this one.
What does that even mean in that case?
It's the same thing. It's just that it has only two possibilities, horizon and equatorial. And now we have like 12 plus options.
Celestial system sounds like something Kepler would have written about. Or Galileo, a system of the world or something. Let's see, what really is this? This is, I mean, it's very similar to the viewpoint and things. And in 3D graphics, what will be the analog in 3D graphics of this?
I mean, that boils down to the question is, what is this thing actually doing? Is it defining your origin? Is it defining, what is it actually setting?
It's like viewpoint. It's the viewpoint. And look, this has the analog of, it has the relativistic analog of viewpoint is the here. Horizon, what is the analog of that in
So because we are always on the sphere of the Earth, we have to specify whether we are looking from the center of the Earth or from a point on the surface, or do we follow the rotation of the Earth or not?
Is Roger still with us, or did Roger drop out? Is Roger
No,
here?
no, I'm here.
Okay, so in the case of 3D graphics, what is the analog of what we're talking about here? Because viewpoint, there's a viewpoint and a view center, right, in 3D graphics.
Yeah. So, well, viewpoint is a little special because that's the old camera model that we have, and it implicitly, when you set viewpoint, you need to be outside of the things you're viewing, kind of like a microscope. So
yeah,
I call it the
right. So what is our new way of doing this?
So there is view vector.
Which is the projected vector. Is that right?
The view vector says where you're looking at, and you have to set the view angle separately. the angle, view angle gets computed automatically when you use viewpoint to always include the whole world, so to speak, the whole plot
Yeah, I
range.
understand. I understand. But so these things, view vector and view angle, should be relevant also for astrographics, should they not?
Yeah, it's just a question of what the convention is of.
I understand, but they define a viewport, basically,
Yeah,
looking at the sky.
yeah.
Okay. I mean, and perhaps we should even support them in astrographics. Unless that's crazy.
Well, in a sense, this is trying to imitate what you would see, while in astro or in geo, we are always going to deform it with a projection.
I see. I see your
Right?
point.
So this is not something you see.
Yeah, okay, fair point. Now, I mean, an interesting question is, why are we never doing that for graphics? I mean, in other words, when we have spherical image, okay, if I'm looking at an object, if I were looking through a fisheye lens, I will be distorting it in the kind of way that we're distorting it for astrographics, correct?
Yep. Yeah, I'm sure there is a projection that imitates that.
Right, but is it the case, Roger, that in a 3D scene, we could imagine a situation where we would make a geographics-like projection of the 3D scene? Yes, presumably yes. I mean, just like you look at the Earth and you project it, you're looking at a 3D object and you can project it.
I mean, we are projecting it. It's just we use a.
No, I know we use a single projection. I'm saying that we, is it possible that we could support? What would be the way that you would take the 3D?
I'm just a little bit confused about sort of, because in 3D we have depth. When you think of.
So do you on the Earth? You're looking at the Earth.
But there's no depth. It's just a 2D sphere.
No. But the point, Roger, is this: when you look from a point, when you look at the Earth, the depth is your distance to a particular point on the Earth from where you are, I think. Right? It's a depth defined only by the shape of the Earth.
Yep.
But then the projection, the reason the projection is non-trivial on something like an what is it called? What the heck is that called?
Orthographic?
Orthographic projection, right?
Right.
That's just taking parallel lines, is it not, from where you are to the Earth, ignoring the depth.
Right.
Yes. So there's a family of projections which are the perspective projections, which are the ones imitating what you would see. And so when you go to infinity, when the perspective is from infinity, you get the orthographic projection.
Right. And we use those perspective projections. That's what we use. That's what the normal.
But I'm saying that there's nothing that would, I mean, it is a pity that things are not modular enough that we can take our geo projections and apply them to a 3D scene. Right?
Why would you
well,
why would you want it?
Immediately, it depends. If you've got something where, let's say you've got a robot and it's in the center of some block world.
Mm-hmm.
We are so used to the fact that we have eyes only in the front of our heads, so to speak, that we're used to seeing, we're not used to seeing this picture that, Jose is showing on the screen here, which is because you need eyes in the back of your head to see that whole image there.
Isn't this kind of what view matrix is used for? I've never used view matrix, but
well, it's an encode. No, it isn't. View matrix can't do this. View matrix is a global transformation.
Yeah, view matrix basically is that projection perspective. You can do both perspective and orthographic with it.
So one of the advantages of the geo projections is that they show you the whole world at the same time.
By the way, I hate the size of the labels here. These labels are twice the size they should be. I just want to say that.
Okay.
Actually, Stephen, speaking to your use case, I mean, I think it's still a marginal use case, but autonomous driving, you know, like a Tesla car has 8 cameras.
Mm-hmm.
But they usually literally show the 8 views at the same time.
Well, yeah, look, I mean, even, you know, my current car has some camera somewhere, and when you park it, it'll show you the as if view from above the car.
I have that too. It's great, actually.
And that's obviously doing some projection, you know. I'm trying to remember what that Tesla that I was driving.
I don't think it shows it in the car visualizations, but when they show it, then they give talks and stuff. That's what they usually show.
Just the 8 views.
The 8 views, yeah. And then you have how that streams into maybe what they call the vector space, which is not a vector space in the mathematical sense. It just means vector graphics.
Yeah.
Vector 3D graphics. But this thing of having multiple kind of views and synthesizing it up, I guess it's kind of maybe growing, maybe.
Right. But I mean, look, I'm just trying to orthogonalize this functionality that we have, right?
Yeah.
It is the case that this notion of projecting could work for any 3D graphic. We are doing it currently for the celestial sphere and the geosphere, so to speak. I'm just making that point. I mean, somebody could make a WFR thing as a test case to make a projection of an arbitrary 3D scene.
Well, maybe it should be the other way around, that geo and astro should be modernized so you can actually see what you're looking at. And right now, you somehow always see everything, which is a bit weird.
Well, look, once we have spherical image, there clearly should be a way to turn an astrographics into a spherical image, which in turn should be projectable into VR. I mean, it should be the case that any of these astrographics things are easy to, render in VR. Right? So that, because in the end, as you say, in VR, that's the full object that you're going to be seeing. That astrographics, circle there. It's a full object you're going to be seeing, except that at any given moment, with your gaze in a particular direction, you only see a small part of that. Does that make sense? Yeah. So, I mean, the point that you're making, Roger, is there could be, if we have a model for the viewer that is of the viewport type, right, the kind that we have for 3D graphics, then there is a viewport that you can superimpose on that image. Could you re-render that so it isn't gray?
I changed this to.
Okay, so that's an additional thing, is essentially the viewport on this, right? Does that make sense to people?
Yep. Mm-hmm.
And arguably, we should support that. And that viewport, just like it is.
What actually happens when you look through a telescope, Jeff? Isn't that like a viewport?
Yes, it is.
I guess. Yeah. So, I mean, you're taking you're just kind of zooming into one particular area of the sky.
And it's circular. It's circular usually. The boundaries are circular.
Right.
At least I don't know about more digital telescopes. Maybe the boundaries are not circular anymore. Are they?
No.
But where do you capture the image on if it's circular?
Your eye.
Well, if you're taking an image, it's going to be a rectangular region, obviously.
That's what I figured.
Right. But so my question would be, okay, so let's assume you're doing astrophotography of this image as we see it here, right? Then, and we got a telescope in a particular direction. The telescope has a certain magnification. It will then carve out a rectangular region from this. Is that correct? Does it just cookie cutter carve a rectangular region out, or does it then reproject it again?
Well, it's a bit like geo when we make a map, right? We are going into a small region and then simply
chopping it out.
Exactly.
Okay.
Once we go into very, very small regions, the projection doesn't matter very much. All projections are going to behave in the same way.
Yeah.
It's when you are looking at the whole thing that projections are very
No,
different.
I understand. I understand. But so we've got the additional thing of where are you pointing your telescope?
Mhm.
And in the case of spherical image and the stuff we feed into VR, we're just going to give them the whole enchilada, and then it's a question of what the actual MEMS or whatever they are that sense direction are, or that's how we pick out which part of this sky image we're looking at, right?
Yep.
Okay. So let's come back now to the observer question. So the question is, where and when are you?
Mhm.
And that horizon piece, remind me what some of the other choices for horizon are.
So the main ones, the traditional ones, are equatorial, ecliptical, galactic, and horizon. And then all of them have modern versions, depending on whether they follow the precession of the Earth or not, and things like that. So there are kind of modern versions.
Okay, but hold on.
So the observer, you need to say you need a point where you are, and you need a
Exactly.
frame.
Mm-hmm.
Is that right?
Exactly. So this defines the three axes centered at this point.
Point and a frame. Okay, yeah, that gives the whole frame, right? The point and the frame, the origin.
But there's a sign to the frame, is there not? The horizon there is you're looking only at the up sky, not at the down Earth. So if I was in space, for example,
Mhm.
okay, then I have a different situation. Then I don't want horizon, do I? Because in space, you can see in all directions.
Right. And for example, horizon will always require a location on a body. And some computations, if you try to do them with, I don't know, you just specify here the Earth, horizon will say, no, I do want a location. Earth
Okay,
is
so
enough.
I want to see, can we try this? Astrographics, try a new line. I want to see the astrographics as seen by Pioneer 10. That should work, right? We should be able to see the sky. Actually, this is a really cool thing. We should be able to see the configuration of stars as seen by Pioneer 10.
I'm not sure.
Or the configuration of planets, rather, will be even more interesting.
I'm not sure I can do this, because I don't think I have a way of specifying as an astro position where the Pioneer is. I mean, it should be possible. I just don't have it yet.
Yeah, okay, fine.
But
so every satellite and every deep space probe should have a, that should be an astro position, right?
We have a heliocoords property that's a list of triples.
Right. And it should be possible to extract it from there. But for example, something along the lines of what you are thinking about is, I think this one. So this is, the ICRS is one of these modern frames, which is centered at the solar system barycenter. And because the solar system barycenter is just outside the sun, looking from here, we see the Earth now there, right?
Yes.
And the sun is huge, because we are just very close to the sun.
What happens if we're very close to the Earth? Does the Earth look big then? If we're looking from the moon?
Well, the size is not correct. The sun would actually be way bigger than what we're seeing here. So
why don't you make it correct?
Well, there is the question of how much to enlarge these things, because if we are always correct to the size, then in most cases, things are points.
Okay, so we're probably going to need an option to control that.
Exactly. So there is a formula which I'm still playing with, which controls this balance between you are very close to it, so you want the real size, you are very far from it, you want it enlarged.
Yeah, it makes sense.
For example, Neptune is tiny, so you don't even see a point here. Or Pluto, which is the name, but not a point.
Well, by tiny, you mean it has low magnitude?
Yes. I mean, it's not visible at the naked eye. And if we compute the actual angular size, it's super tiny.
Well, maybe we need something where there is a color, a gray color, for example, that we show objects that wouldn't be visible. I mean, no stars are gray.
Mhm.
You know, I mean, you have Antares there, which is some kind of yellowish color there, I notice,
Mhm.
and which is all well and good. But in other words, you could have a thing that represents this is a fakely puffed out thing, and it's gray.
Mhm.
See what I'm saying? I
Yep.
mean, honestly, you could use gray, you could use green, because no stars are green.
Perhaps the names, perhaps the planets should have a different color in the name.
Perhaps so. Yes, I think that would be a nice idea, or some different rendering. I mean, you could also give their astronomical symbol right
Mhm.
before the word. That would be
Yep.
another way to show them, to distinguish them.
Mhm.
Might be kind of nice. Again, there's design questions, so please, Aubrey, please collect this. These are design questions.
Gotcha. Understood.
Okay, you're really hard to hear still.
I'll play around with it a little bit more.
How do you deal with something like Andromeda? Just curious.
The Andromeda Galaxy?
Yeah.
Or the constellation?
The galaxy, you know, just
Andromeda.
So yeah,
Traditionally they're drawn as ellipses. I've even done some mock-ups, though I don't have them ready for this. They're not incorporated into this at all. We actually have position angle and major and minor axes for most of the galaxies, or at least the bright ones anyway. So in theory, we do have the data to render them in their correct orientation and size. Most of them are very tiny at this scale. The Andromeda Galaxy would be visible, but I don't know how much data we want to have like shipped in product, so it's just ready to be rendered, and how much you have to query from entity values, since entity value is kind of slow to get all that data in real time.
What are we talking about? I mean, if you have galaxies, okay. So here's another point. You know, I'm looking at the sky in a particular, you know, orientation. At some point, I want to see the cosmic microwave background. I want to see all the way back, you know, 14 billion years or whatever. At some point, I might want to see what are the galaxies in this direction. Am I making sense?
Yeah.
Mm-hmm.
And I mean, you know, what you're showing here, where's the center of our galaxy? It's presumably over there on the puffy thing.
Yeah, over there by Antares, between Pluto and Antares there. Yep.
But we're not marking the center of the galaxy.
Not yet. We could, but
I think we should mark it in some way. And okay, all right. Let's come back to the Astro Observer question.
mm-hmm.
So the initial thing is a frame. It's in general a signed frame, correct?
Yes.
So there's a all right. So again, in space, what is the frame that you're going to use? I'm confused. I mean, in why is there? You're at a point.
There in space, there are always frames defined by the distant stars. And for example, this ICRS frame is the International Celestial Reference System, which plays a bit of the role of the ITRF in geography. And this is a frame that is fixed with respect to distant stars.
Okay, fine, but that's an all the way round frame. That doesn't have a you can't look down type frame. Because on the Earth, the horizon frame has a you can't look down feature, doesn't it?
Yes, though it's typical in astronomy to consider the Earth is transparent, and so to present this type of plot in which you see the down too.
Okay, but the circular one that we had didn't include down. The circular one was cut off at the edges of the circle.
Correct. If you do the
Right.
Lambert azimuth one, yeah, you're using
Right.
the
So when you say horizon, when you say astro observer arrow horizon, what do you mean? Do you mean one that is cut off, that one there? What do we mean here?
You mean the coordinates are measured in altitude and azimuth is basically what you mean. Angle above the horizon is azimuth or altitude.
Okay, listen. The observer should presumably specify, do you want to see down or not? That shouldn't be something that's implicit and has all those weird things hanging off the edges and things. That's implicit in the astro projection. That's a feature of the observer, is it not? Whether the observer is a eyes on all sides of its head alien, or whether it's us standing on the ground or something. Is that true or not?
I think it would be more like a visualization of things, right? So we could have an astro styling like in Geo, and then we defined all these various colors, style.
No, but that's not the point. The point that I'm making is, do you see down, right? In this picture, you are cutting off things below the horizon, correct?
Right. Yeah, the horizon is here.
Okay.
Yeah.
Okay, fine. So what I'm saying is, how do you specify that? Is astro observer arrow horizon telling you to do that or not?
I think that's a styling thing, not an observational physics thing.
Correct. Because a lot of times you'll observe in the altitude azimuth horizon system, but you may want to turn the ground on or off. Many programs will allow you to turn the ground on or off.
Okay, but it shouldn't be styling. We should not call it styling. That's a very fundamental thing. Whether you include, I think that should be part of the observer thing. I think it should be something packaged together with horizon, and it should be horizon, up only or something.
But I mean, this is something that is the same freedom in the second argument of astroposition. And so if we include things here that are not useful in astroposition, it doesn't play well.
Okay, but here it's an option. In astroposition, it's not an option. So that doesn't work for me. I mean, in other words, this. Okay.
I see. We could have parameters here additionally to those that astroposition takes.
Astroposition, does astroposition have refraction or not?
Yes, it does. So yeah, so these are the collection of frames we have. And then these are the parameters that currently astroposition takes.
So it doesn't work the same way. Where's the here in astroposition?
It's also here. It's the location. It's just that.
But you can give it not
exactly.
Exactly.
This is some sort of shorthand notation. These three are so important that they are understood in a different way.
Okay. So you said the other name for this in the sun position was celestial system.
Yep.
It's a very obscure name.
I think it was something Itai suggested.
A funny thing here, which is fundamental to astronomy, is the time, right? There's no such thing in our geography.
Yep.
Right.
Or graphics, it's just not there.
At this time, there isn't anything with graphics. Let's see. So
if you just object to the name observer, what about astroviewer?
No, because that's not the thing I'm objecting to. The thing I'm objecting to is this is defining, there is a whole giant space-time thing laid out there. And you're saying there's a now, there's a here, where are you looking at this giant sort of
It looks to me like all the other options are dealing with projections, like astral range, astral projection. That astral range talks about coordinates in the projected space, right? Looks to me.
Yeah, it does. No, yes, this is saying in Astro Observer is a little bit more like Astro Range, because Astro Range is telling you of the whole sky, what part of it are you looking at? Am I correct?
Yes, that's correct.
Okay, so Astro Observer is saying, and what coordinate system am I going to use? And by the way, what part of space-time, the now and here and so on, am I looking at?
So this is from where you are looking at, and these are angle ranges in this frame to look at.
Yeah.
I mean, this follows. I've tried to follow geographics, and there is
No,
also
I agree. Astro
Center.
Range is okay. The only one that isn't working is Astro Observer.
Yes, that's a new one with respect to geo. Yes, in geo, effectively, you are always doing mapping from the center of the Earth.
Okay, what you've got there is you've got, okay, what is it called in astronomy? What is frame? Is that a common thing it's called?
Yes, reference frame and reference systems are the two names that are typically used. So in recent decades, a difference has appeared between reference frames and reference systems. And that's, for example, why we have ITRF and not ITRS. And so the distinction...
What is the difference? Yeah, go ahead.
Yes, the distinction is that the reference system is the ideal reference that you're talking about, and the reference frame is the realization. And so every few years, there is a technological better realization of the same reference system. And that's why we have ITRF 00, ITRF 05, ITRF.
So what is this thing, Astro Observer? Is it a reference system?
It's a reference system, effectively, yes. So this part is a reference system. So the event in space from which you are looking at and the orientation of the axis. And then there are physical modifications. This one, right? Are you considering light deflection by the sun or aberration? So in astronomy, it's very typical that...
And those are the things that makes it a reference frame rather than system, the non-idealness of it.
No. So here in Astro, I'm just referring to the ICRS, but there is ICRF1, ICRF2, ICRF3.
Okay.
And those are progressively more and more precise. I'm just using the last one.
Mm-hmm. But they're more and more precise because they get better gravitational time delays and God knows what else, right?
Exactly. Better VLBI measurements and things like that.
But these things, the aberration and nutation and all that sounds like models that can be improved over time.
Yeah. Yeah.
So this is a model that improves over time, indeed.
Right.
This is a formula that makes light appear to come from a different place when you are observing it while moving.
Right.
And it's a formula that is implemented there, and people worry about how much is that contributing to my measurement. So you can activate it or deactivate it to see how much of a difference that makes.
Okay, so Astro viewing system. Astro, I hate reference system because it's just such a weird, meaningless thing.
Astro Center, would that make sense?
No, doesn't make any sense at all.
No, there is already an Astro Center. You can say Astro Center is this star, Astro range 3 degrees. And that imitates a telescope.
Well, I think Astro reference system is the least bad.
Mm-hmm.
I hate the fact that we've got things like refraction and aberration in there. I mean, we could go, it's a bit obscure, astro system or something.
And method, something related to astro method,
No,
observation method.
No, because where you are is hardly a method. I mean, maybe there's two options here. Maybe there should be two different options. You know, astro effects, and that's where you put in, you know, polar motion, refraction, et cetera, et cetera, et cetera. Should have astro base and astro effects. See what I'm saying? Where astro base, I mean, I kind of like astro base for the here and now, so to speak.
Mm-hmm. I see what you mean. I think I was trying to keep the same objects here and there.
And where?
Here. It's
No,
the very same object.
I know. What's CSIS?
Coordinate system. So once you have defined a frame, you can say, I want spherical coordinates or Cartesian coordinates or cylindrical coordinates or projected coordinates.
Okay, but having astro effects as a separate argument, I mean, as an option to astro position seems okay to me. You know, we have some default, and then if you want to switch on and off aberration, you can do that with an option.
I see.
And then what would happen here is that astro base would become also an option to astro position.
You mean we can feed it via this second argument or the option?
Yes. I'm kind of liking astro base, but can we justify the first element? Astro base.
And that would be just the noun here or also the orientation?
I mean, look, to me, astro base, astro frame, astro effects are three separate things. Are they not? I mean, that horizon thing is a frame. So all those, right?
It's
different.
An orientation. It's an orientation.
They are different, but they are related. For example, the horizon must be defined by where. So they have to go together because this horizon is depending on where you are.
I understand, but there's a default for astro base, so. Look, I mean, I understand the frame needs a base point.
Mm-hmm.
I still think it should be three options: astro frame, astro base, astro effects. That's my suggestion. Now, let's say we did that for astrographics. Now your concern is, what do we do for astroposition?
Right.
Okay. We've got the frame.
Now, I mean,
how often?
It's interesting that frame in mechanical systems include the base point. I mean, you need to know where the coordinate system is.
Well, so do you here.
No, but you seem to. There seems to be only orientation. What do you call frame here?
No, it's got the base point. That's the here.
Yeah, no, it does a here. You know, that's there. But if you were splitting them, you were splitting up frame as only being orientation.
Yes, because most of the time we are boring Earth dwellers. That's why it doesn't matter much, because here there's a, you know, for many purposes, here, you know, in a mechanical system, you know, whether the bulldozer is there or down the street or whatever. You have to define that.
Well, but you know, like in a you know, like a robot with robot arms.
I know, but it's obviously you need to say where it is. But in this case, there's an obvious canonical sense of where it is, which is where you are.
Okay, yeah.
Right. So therefore, you do not need that to be as prominent because there is a totally obvious default. And a different default is, well, if I were in a spacecraft, what would I see? Is a completely different and much more obscure thing. Right. And I mean, I assume, by the way, that you can put telescopes in the here position and that it correctly picks up their geopositions.
We can do that.
You know, if I put Keck telescope or something there, it should work.
And anything that is a geoposition will work. If it has a position property, it will work.
Okay. So, okay, my proposal would be, it is astroframe, astrobase, astroeffects. All right, and that what we do here in this is that the default is that that frame is just the frame. You could specify it as astroframe arrow, or you could specify it as a naked value of the frame option. And if you want the other things, like, well,
From where you are looking will always be very important. These three you keep all the time, specifying them.
Yeah, I know, but they're different things. They're different things. Well, I mean, maybe you can just have a triple there. And that's or you can specify it with options. So you either have a triple that's frame, comma, the elements of astrobase. But now, look, in astro distance, you were saying, in astro distance, you don't need the here, but you do need the now.
Yes, I think in astro distance, what I was planning is, because in astro distance, you always have to specify who is looking at whom. So I think I got it wrong. So it's astro distance of, I don't know, Mars.
By the way, this bug with the thing showing in the magnified view uncentered is really annoying. Okay, go ahead. Now what?
And then I think here, I mean, the horizon here doesn't play any role, but currently it's needed. So I can say now,
bad.
Now plus, yes, I realize that. Quantity 3 years. And then here, you say where.
What do you mean by where? This is a mess.
So this is saying, give me the distance observed by Jupiter. So this is the distance of the light travel from Mars to Jupiter observed by Jupiter on this date.
I understand. I think that's a mess.
Oh,
Okay,
I use precisely one that requires a location. So here we place any frame compatible with this location.
I know, but I just think it's a mess. I think it's a mess. I think we got to have an astro distance where you can just give two objects and a time.
This shouldn't be here. I mean, the nice thing would be astro distance of Mars and then Jupiter, comma, date. And it says, this is the date of Jupiter.
Well,
like your dated.
Dated.
Okay. Exactly,
dated.
yes. Yeah.
Just use dated.
Yeah, I agree with that.
Right, so that deals with the date. Now, I have to say, you could have the dated wrapper around either of the objects. And if the objects are 5 light years apart, that's going to matter.
Yes. I mean,
which is good.
Exactly. There is always the emission problem and the observation problem. So who is
dated?
Yeah. Oh,
Not dated.
Yep, dated. Yeah. So
right. So that's good that we have dated, that we can put the date wrapper around either of them. And I mean, we have to be able to say, in the case of geodistance, it's symmetric. Doesn't matter which, who's coming, who's going. In this case, we'll have to define, I don't know which way around it should be. I mean, I kind of think it's from to. Like in travel distance and travel directions, it's from to, right?
Mm,
Am I making sense?
yes. Yes, because it's a list of
Why do you think
different
it's
steps.
symmetric?
Geodistance is symmetric. The distance from New York to Los Angeles is
No,
the same.
I'm just saying here, if you dated Mars.
No, it's
by-
not symmetric. It's not symmetric.
Okay.
It's not symmetric because the distance, things could move in the time that you're defining a date, and there you've got to define the coordinate system you're using about what that, what the simultaneity surface is.
Yeah, exactly.
Okay, but so. Okay, so we've got some solution here for astrodistance. So let's go back and look at I mean, an interesting question is, let's say I want to do astrographics of the position of Mars on 20 days through the year.
Yes.
Then presumably what I should be able to do is to say astrographics of dated Mars, comma blah, dated Mars, comma blah, etc. At which point my astro base really shouldn't even be there.
So this is this example in which we take Mars on this number of weeks, like 50 different weeks.
Yeah.
And then we plot them here on a map taken today. So this is a current map. So the sun will appear where it is right now, but we simultaneously place all these positions for Mars. And so we see retrograde motion here, for example.
Mm-hmm. Okay, but your point then is that to say in astrographics, dated of Mars, inside the astrographics as part of the primitives, does or does not make sense?
Well, I think it does, yes. In this case.
Okay, let's go back out. Let's go back out to him. I am pretty certain that this thing about breaking these into three options is the right thing. So let's just see what I mean, in astrographics, there's no problem in breaking them into three options. Is that a true statement?
I think it feels more natural in astrographics, yes, because it's based on options.
Right. Okay.
Here,
so let's look at astroposition. So astrodistance, again, in astrodistance, astro base, we are not wanting to put in there as instead, I mean, astrodistance should probably support astrodistance of Mars, comma, astro base arrow sun, for example, potentially. So the options are the ultimate thing, and there are shorthand notations that are arguments. Am I making sense?
Yes, though in other cases in which we have an argument and an option, so far the argument always wins when you specify both.
Okay, that's fine. Then that can be that way. I'm not defining that here. If that's what we've done, then that's what we should do. Okay, so let's go back again to astroposition. Okay. By the way, I'm very impressed with all this functionality. I mean, it's all great. Anyway.
And I want to show you an example that you will like in a moment.
Okay. Okay. So I think what you're saying is, in astroposition, we probably should have the possibility of having that second argument be a list that has here, now, and the name of the name of the frame. And we probably should allow them in any order because there's a string, there's a this, that. We kind of know what they are.
Yeah.
And that's just, it's just the frame bucket, so to speak, or the reference system bucket. But otherwise we separate them out as astro frame, etc. That is my proposal. And if we had to give that argument because we want to get the celestial, because we want to get the coordinate system, you could say automatic, and then you give a bunch of options for astroposition.
Actually, that's an input. In output, I could canonicalize to effectively what there is right now.
What do you mean what there is right now? You mean with the frame?
In which everything gets collected into a third argument, into a second argument. Rather than
With the astro effects also, that's fine to canonicalize. I think canonicalization is good. But then you've got to do things like define the order of the astro effects and so on. If you're really going to canonicalize.
Yes, just to have a canonical form.
No, I agree. Canonical form is good, but I'm just saying you got to decide that it's aberration first, then refraction, then whatever. I think there's some trickiness if you say option of astroposition, comma, astro effects. What do you get? And perhaps you should be able to, perhaps that should re-extract it. Slightly tricky. Okay, but show me the example you wanted to show.
It's this one. So, so let's look first at this image, which is the image of Eddington's observation in 1919, in which he was looking at this solar eclipse, and he was looking at these various stars in the constellation of Taurus.
Okay. So, is that the actual image?
Yes, this is one of the images, but this is considered probably the best of the images he took.
Okay.
There were actually 2 expeditions. So this is one. He was in one of them, and that's the one I'm going to use here.
Okay.
So this is the date of the observation. I mean, we can get it from solar eclipse, roughly. And we know that he was in Principe Island. So these stars in our collection of stars, in Jeff's collection, have these names. So these 6 stars are these 6 stars.
Really? There are ones that are just in the Hipparchus catalog that weren't named in Eddington's time?
I guess they were named already.
Well, then why are they called HIP, whatever?
That's a much more, I mean, that's a Hipparchus catalog number.
Exactly.
I know, but what were their names in Eddington's time?
I don't, off the top of my head, I don't know.
I mean,
they have. I mean, any given star has usually many different names. So
no, I understand that. But I'm asking the following question: okay, but if it was called Upsilon Tauri, and we're naming it Hipparchus 7364, is that really the right thing to do, or should we canonicalize to its more common name? That's all I'm asking.
We can definitely pick something more common. I'm kind of surprised that a star that showed up in that catalog is actually known by Hipparchus. So I'll have to look at that.
Exactly. That's why I'm saying that's probably
Hipparchus is like our fallback. Usually, we try.
No, I understand. That's exactly what I was. That's exactly what I thought was the case, and therefore I'm surprised.
Right.
Okay. Compute their equatorial positions.
Right. So this is just to place them in the map. So this is astroposition, computing the positions of these stars, the 6 of them, in that. Sorry, I have to change this. Okay. But these are just the positions of the stars in this day. And then this is a manipulate showing I have this, sorry. I have these defaults, which I don't want to have. So let me repeat this quickly.
You have saved definitions goes to true. Is that going to mess you up?
Oh, let's see.
No, not if you rerun it.
Okay. So now this is time. So I'm going to look at 6 hours to 18 hours, so 24 hours around that date that we picked here. And so these stars, these 4 are these 4. So this is just rotated. So I'm using a different frame. And this star is this star.
By the way, it might be nice to actually get the frame the same. I mean, just to make sure we can do that. From the horizon, from Principe Island or whatever, presumably he had his feet on the ground, so to speak, and that defined his orientation.
Could be.
Maybe his
Could be, but-
telescope turned things
Yeah,
upside down.
exactly. The telescope could have been rotating on an equatorial axis to track it, though. So it's like things are going to be on a circular.
Okay, but I just want to make a point about that.
Yep.
In terms of astrographics, some of these things, like telescope images, is reflected, or the telescope is on some equatorial mount or whatever else. We should have a nice way to parameterize those things with respect to what astrographics actually shows.
Mhm.
Okay.
Okay.
Show me the gravitational effect.
So this is what happened. So here we see, so that's the sun, that's the moon that comes at some point, and so we can see when the eclipse happened, right?
Yep. But the stars seem to be very fixed here.
Yes, the stars are. That's why I'm using the equatorial frame, right? Because in that frame the stars are fixed.
Yeah. Okay, I understand. But where's the gravitational?
So the thing is that the effect is absolutely tiny. So we get more or less that the moment in which he took the picture was 1.1 hours after the date that we chose. So this manipulate is just to select the time, because for example, further down, the sun touched this star, but of course this was not visible anymore.
Yeah, right.
But this other moment was about 6, something like that, right?
Mm-hmm.
So now we compute this function, which is the position of this star, which is this one, and with or without
separation. Yeah,
exactly.
Cool. And so when the thing came very close to the disk of the sun, that's when there was the peak in that difference.
Exactly. What he observed is about 1 second, which is this moment, right? 1 hours is when the eclipse occurred. But he knew it was a 1 over r, r being the distance to the center of the sun. So if you compute the moment in which the sun touches the star, it's about 6.5 hours. Then we get the famous number that is in all books, the 1.75 arc seconds.
Which is not what he observed.
Exactly. He couldn't observe that, right? I mean, the 1.575 would have been when the star touched. Sorry, when the sun touched.
So if he'd been lucky and the eclipse had happened on a star field that contained a star that was really close to the disk of the sun, then he would have had a bigger effect.
Exactly. But I mean, it wasn't much of a difference. But I mean, perhaps he could have gone to some place in the ocean in which the perspective could have been better. But of course, he couldn't take a good picture.
Yeah, right. Very interesting. So that island, I mean, if you okay, just for the fun of the blog post you might write about this, I mean, you should figure out whether there's any spit of land somewhere, whether the ocean is way too deep in that part of the world for there to be any. I have no idea where Principe Island is.
So something interesting. This part here over 1.75 is completely spurious. So this is when the star is behind the sun. So this is computing something that, because the formula is just the distance from the star to the center of the sun, it predicts something bigger, but this is not visible.
What's the y-axis here? I'm sorry, what's the y-axis?
This is the deviation in arc
that's
seconds.
Time. Oh, the y-axis is deviation. Yeah.
Deviation in arc seconds.
Time in minutes versus arc seconds.
No, it's the distance, the deflection of light by the sun. That the vertical axis is the amount of deflection in arc seconds.
Okay.
And the x-axis is the time in hours.
Right. So notice that the size of the suns is about 2,000 arc seconds. So measuring one is quite a thing.
Yeah, it's probably nonsense. It was probably complete nonsense. This is the cautionary tale for those of us who have, because in our model, not this particular thing isn't the thing, but there are other subtle effects that one has to measure, and you have to have a experimentalist who's unfortunately it's not a purely objective, cut and dried question, sadly. All right, we are going to have to wrap this meeting, and I think we're going to schedule another one of at least the same length. But in the last couple of minutes, what do we have that we can look at?
So this is another cool example, which is the distance between the sun and the earth. in miles, and you see it changing in real time.
That's really cool.
Or this one is precession.
Yeah, I see that. What about
This
the sun, about the Earth and the Moon? Could I see the Earth and the Moon as a dynamic? Could you go back up and then just recompute that with the Earth and the Moon? Oh no, why don't you do that in feet instead of miles? Oh boy, wait a minute, how can that be right? Oh, I see. You need to do it. Oh, I see. That's counting in feet, so it's moving. So we really need to do minus the mean distance or something.
Oh, I see. Yeah, but you get a feeling of the speed of change.
Yeah. Wow. Amazing. Oh, sorry, show me the equinox.
Oh, yes. So this is precession. So this is the equinox. So this intersection between the ecliptic plane and the equatorial plane, and this is the new modern axis of something that moves much less. And so this is the angular separation between both, and so this is what the precession of the equinoxes is proceeding. So it takes 26,000 years to give a full round.
I thought it was 23,000 years. Which there's all these different cycles. I forget. Is that right? 26?
I think it's 25,700.
Okay.
Yeah, but you see here how the equinox is moving. And so in the 20, so many of the star data.
A couple of suggestions here on our live stream.
Mm-hmm.
One is, why don't we catalog astronomical events like black hole mergers, supernova? I think we have supernova explosions, don't we? Do we have supernova explosions as entities?
We do have some. The set hasn't been updated in quite a while, but we do have a set of entities.
But those entities have both a position and a time.
Well, they're typically in a host galaxy that has a right ascension and declination. So yeah, they have right ascension and declination, and distance is usually known, I think.
No. Jeff,
yes.
We now have astroposition. We should be returning the astroposition in space and time of a supernova explosion. You see what I'm saying?
Yeah.
Not that we have to look through 17 different properties to find the place and time. You see what I'm saying?
Yes.
No host galaxies, no whatever. And similarly for black hole mergers, it would be really nice, since there's a finite number of them, to just have the to have it be the case that you can plot on the sky, where have all the black hole mergers been? What happened? What were the black hole mergers last month? Plot them on the sky. Does that make sense? We should be able to do that.
Yeah,
right?
We need some kind of a data feed, because probably people are going to be interested in the most recent ones.
By recent, we mean it happened 3 billion years ago. But it's recent as far as we're concerned.
Yes.
Another comment from X something on a live stream is about generating videos and frames and manipulates and so on. Yeah, I mean, that wasn't too hard to generate, right? That picture of it should just be a manipulative in astrographics with the time, right? That should be what you need to make and then you should be able to turn that into an animation video just directly and straightforwardly, correct?
Yes. So I have some examples here of, let's see if this works. So of course,
I think this will dovetail with other functionality in that we want to take basically manipulate, and instead of you manipulating them, because you can rarely manipulate more than one slider simultaneously with one hand, that you can coordinate moves and make movies that way. Do you know what I'm saying? It's like you direct.
Mostly, but the most important thing here is the one parameter, which is time.
Sure. Yeah.
And I think making an animation video as a function.
In that case, it should just work, basically.
Right.
Yes.
I'm now wondering in this astrobase thing, maybe we should even break it into astrobase is the position, astro time or something is the date. Because often you just want to change the date and nothing else. So why are you messing around with the position as well?
Well, the way I see myself using it is because these, in astroposition, for example, because the second argument is quite flexible, you can put it there. And it will understand it immediately that
the time, just stick the time there. And the
exactly.
Other thing, yeah, that's fine.
You can say the time here or a position, and it will take now by default, or the frame, and it will take here and now by default. Well, actually, no, each frame has a default. For example, I don't know, these ones are centered at the solar system barycenter. So each frame has a default location.
Yeah, I see. That's fine. Right, so you give those, so fine. So, I mean, so the issue there is that sort of do anything option. You want some name for that, for these other functions as well. You want something where you can use the same packaging for the other functions. And I think you know, where the other functions you might break apart astro frame, et cetera, or you might package them all together. I still think astrobase is the least crazy thing for packaging them together. And look, if you're going to have them packaged and in any order.
And what about an association? And we can place names inside.
Maybe. Let's think about this a little bit more. I mean, okay, can I get a sense of just in terms of the scoping of other things we have to discuss in Astro? By the way, those were really nice demos, particularly the Eddington one.
Thanks.
Can I just get a scope of what else we need to look at here?
So these two, astroposition and astrographics, are the fundamental functions. The other ones are auxiliary. So together with astroposition, we have angular distance, magnitude, and distance. And together with astrographics, we have its options.
Okay. One thing I'm a little bit confused by. Okay. So angular separation, astro-angular separation is the analog of astrodistance. Astrodistance is the actual by spacecraft distance.
Exactly.
Whereas astro-angular separation is projected.
Yeah, that's an angle.
Yeah. I do think it'd be really worthwhile to like get these black hole mergers and things like that. And are there any other events? Do we have gamma ray bursts, all those kinds of things?
No, because there's not any one catalog. There's multiple missions, and so finding a canonical source, you know, there's different events, different sources.
Take a look. Let's try and figure it out. Because I mean, I think now that we've got astroposition, we've got a meaningful thing to return for all of those different events. Am I making sense? Now, I mean, it should be the case that if we have the astroposition, if we have it specified correctly, black hole merger happened. Okay, here's an example. Right? Actually, this is really cool. I mean, we should know. We know this black hole merger. We know. Maybe we know its distance. I think in most cases we do. And then what we've got is basically we can say what was the order of these black hole mergers as viewed from another black hole merger. Because the astroposition will be given in the time for us at which that merger took place and its coordinate position in the universe, right?
Well, at the moment, the observers are limited to be inside the solar system, which is where we know well the physics of what's going on. I mean, once we go outside the solar system, the relativity is much less known.
Why? I mean, we don't know it to that precision, but we should be able to say from, okay, for the black hole merger that just happened last week, what was the sequence of black hole mergers that happened for it in the past year? Based on the ones we've seen. And obviously the order will be completely different from the order as it is from Earth.
I mean, we would have to make some strong assumptions, like the space is nearly flat outside the solar system, things like that. No deflection of anything, etc.
Well, I mean, we know cosmologically, we have a cosmological standard model.
Yes, but there is no cosmology at all here. I mean, going be outside the galaxy is even more complicated.
Within the galaxy, I think it's really hard, because then we'd have to have all kinds of, gravitational lensing around random stars and so on. That seems really hard.
Right.
I think in cosmological length scales, we have a standard cosmological model, and it seems not impossible to deal with that.
Yes, but I don't know how to merge the relativity of the solar system, which is done with our first order post-Newtonian expansion, etc., with the cosmology. That I don't think has ever been done.
That requires some thought. But Jose, you're well equipped.
I might understand how it's done, but it takes time.
Yes.
This is something to consult with perhaps experts.
Yes.
How that's done.
Yeah. I think some of your relativity friends might be relevant here. Yeah. I mean, probably nobody has tried to do this. I mean, why would they have done? But
I guess the Gaia team is the more advanced in this type of thing. And they do have long discussions about the relativity, even around the spacecraft itself.
Which spacecraft? What?
The Gaia. They have a special coordinate system defined for Gaia.
Well, yeah. We could ask them. Yeah.
That's the most advanced I've seen.
Okay. Well, very interesting. But we should at least get astropositions of these, sort of cosmological scale events. And yeah, there's of course one incredibly obscure thing, right? Which is the astroposition at the beginning of the universe. for which we necessarily need cosmology. So I agree that is very hard to, because otherwise, it's an astroposition which is in all directions at the beginning of the universe.
Right.
That is tough. So we won't ask for that this week.
It happened everywhere 13.8 billion years ago.
Yeah, right. But most of these things are point things.
Are there, Jeff, maybe are there actually elements in the Gaia catalog that goes that far back?
The Gaia catalog is mainly focused on things in our galaxy, as far as I know. I don't think it looked at cosmological sources. I could be wrong about that. Its main purpose, though, was to catalog structure of our galaxy. So it mainly was measuring proper motion and stuff of stars within our galaxy. That's not to say that the images didn't contain images, but I don't know that they measured. Right. Yeah.
Well, exciting stuff. Okay, I got to go. Thanks, guys. We should schedule another meeting and see you all soon. Bye for now.